Hello, everybody. Let's talk about dilations. Yeah, that's right. We're going to talk about dilations, but today we're not talking about what happens when you go to the optometrist and they want to do an eye exam. We're talking about the kind of dilations that happen in geometry. So, I want to tell you a little bit about a friend of mine. This is Kent. And Kent, as you can see, got a really sweet family portrait taken. And he wanted to put his family portrait in a frame, but as you can see, it doesn't really fit very good because the print that he got was a wallet size and the frame was like a 5 by 7 frame. So you know what he had to do, right? He had to take that wallet size picture and he had to go back to the photo studio and he had to get what we call an enlargement, right? He had to take the picture and he had to get a bigger version of it. When you take something and enlarge it or reduce it, when you make it bigger or shrink it, and it stays the same shape and proportions, this is what we call in geometry a dilation. A dilation can mean your preimage gets bigger, or it could mean your preimage gets smaller. Okay, when we say that it maintains the same proportions, what we really mean is that the dilation takes a 2.5 inch by 3.5 inch photo and turns it into a 5 by 7 photo. And if you notice, that's proportional because the top doubled and the bottom doubled as well. For a dilation to be a dilation, it has to be proportional. The image and the preimage are the same shape, they're just different sized versions of that shape. Okay, so here's what it looks like on a coordinate plane. Let's say you've got triangle ABC, and point A is at -1, 2, and point B is at 1, 0, and point C is at 0, -1, and you can verify that just by looking at the graph. And let's say you wanted to make triangle ABC twice as big. What would you do if you wanted to double the size of triangle ABC? Well, what you would do is just take all of the coordinates and double each of the numbers. So A prime wouldn't be at -1, 2, it would be double that. The -1 gets doubled and becomes a -2, and the 2 gets doubled and it becomes a 4. And we're going to do the same thing to make a B prime and a C prime. And if you look at all those coordinates, all the coordinates just got doubled. And when we plot out those coordinates, guess what happens? Triangle A prime, B prime, C prime is a dilated version of triangle ABC, and it's twice as big. So basically, all of these x coordinates and y coordinates became new x and y coordinates, but when you do a dilation, the x coordinates and the y coordinates both get doubled. Okay? This is what we call a scale factor. The scale factor is what you multiply the preimage by to get the new image. And in this case, we multiplied everything by 2 because we wanted the size to double. Scale factor. All right, so here's an example. In the figure, triangle x prime, y prime, z prime is a dilation of triangle x, y, z. Find the scale factor of the dilation and classify it as an enlargement or a reduction. First, can we classify it as an enlargement or a reduction before we do the scale factor? Yeah, I don't know that I have to explain this, but an enlargement is when something gets bigger, and a reduction is when something gets smaller. Okay, so how do we know if this is an enlargement or a reduction? Well, which triangle did we start with? Did we start with the bigger one, or did we start with the smaller one? We started with the smaller one. How did I know that? Because that's triangle XYZ without the apostrophes, and the one with the apostrophes is where we ended up, and guess what just happened? It got bigger, so this is an enlargement, not a reduction. Okay, now we can find the scale factor. The scale factor of this enlargement is what did you have to multiply everything by to make it grow? Did it get twice as big, or 2.5 times the size, or 3 or 10 times as big? Well, here's what we're going to do to find the scale factor. We're going to figure out that point y and point y prime are at the following coordinates. Point y is at 3, 2, and point y prime is at 6, comma 4. You can verify that just by looking at the coordinates on the graph. And we're going to ask the question, what number do you have to multiply point y's coordinates by to turn them into the coordinates of point y prime? Well, the 3 got doubled to turn into a 6, and the 2 got doubled to turn into a 4, so I think that means that the scale factor on this problem is, well, we doubled everything, so the scale factor is 2. All right, that wasn't too bad. We were able to identify it as an enlargement with a scale factor of 2. Now, all of the examples so far that we did had a scale factor of 2, but you can have a different scale factor. You can triple the size of something, okay? You can even quadruple the size of something. Or you can make something half the size. If your scale factor is 1/2, what you start with is going to give you something smaller. And what just happened really quickly on the screen for some reason was a little note telling you that when the scale factor is a fraction like that, it's going to be a reduction, not an enlargement, which kind of makes sense because a scale factor of 1/2 means it's half as big, which means it's going to be smaller. All right, let's summarize. What's a dilation? A dilation is when you enlarge or reduce something, but it keeps the same proportions, or in other words, it keeps the same shape, but a different size. The scale factor of a dilation is what you multiply the pre-image by to get the new image. So if it doubles, the scale factor is 2. If it triples, the scale factor is 3. If it's half as big, the scale factor is half. So if you wanted to write arrow notation for a dilation, then what you do is whatever that number is in front of the x's, that's your scale factor. So if you doubled it, it would be 2x comma 2y. If you tripled it, it would be 3x comma 3y. If you made it half as big, it'd be 1/2 x comma 1/2 y. And that is basically how dilations work. All right, thanks for paying attention, thanks for listening, and thanks for learning with me, and I will see you tomorrow.